welcome. Here's a big worksheet. This will be the algebra concepts that we feel you should be very solid with for chapter 1 of this course. And I'm going to go through maybe not quite half of these, but about half of them with you, and you'll be responsible for the remainders of these. So let's get started. Write the slope-intercept form. So slope-intercept form, y equals mx plus b, where m of course is the slope, b is the y-intercept. And we'll be doing this for a number of problems at the beginning of this worksheet, but it doesn't get any easier than when they give us the slope and they give us the y-intercept. So this would just be y equals m, our slope, -3 times x plus our b value. And of course we should write that as y equals -3x minus 4. Now you would not be required to show that step. We would certainly expect at this level we can all make the leap to here. So problem 2, very similar. Problem 3, again, write the slope-intercept form. Well, what we notice about slope-intercept form is that y has been isolated. So we often just say slope-intercept form starts with s. Think of s standing for solve for y. I've got some options here. I could subtract 3, then distribute 5/2 to the x plus 2. I'm not a big fan of working with fractions if I don't have to, so I might just choose to multiply both sides of this equation by 2. You'll see what happens. 2 times the y plus 2 times the 3, 6. Now on this side, 2 times 5/2 is just 5, and we're left with x plus 2. And I'd often see the question, well, why don't I multiply the 2 times the x plus 2 or distribute it through there as well? Well, if I was taking 2 times 3 times 4, do I distribute the 2 to the 3 and the 4? Well, we know that 2 times 3 is 6 times 4 is 24. But if I distribute the 2, I get 6 times 2 times 4, 8, 48. The fact that these are multiplied, I only have to multiply the 2 by one of those factors. So now if I continue, I've got 2y plus 6 equals 5x plus 10. I'm going to subtract 6 on both sides in my process of solving for y. 2y equals 5x plus 4, and divide by 2 for a final slope-intercept solution of y equals 5/2 x, 4 divided by 2, plus 2. So writing slope-intercept form would involve solving for y. So a real quick example here, let's take a look at number 5. I'm going to leave 2y, I'm going to subtract 3x on both sides. 2y equals -3x came over and joined minus 2. Rescue 2 with division, and y is -3/2 x minus 1. So no real problem there at this level, I believe. You got a couple problems similar to that you can try in numbers 4 and 6. Okay, again, slope-intercept form. S, solve for y. That's our y equals mx plus b. But when they give me a point that the line passes through and a slope, I'm going to start with point slope form. And point slope form is y minus a y coordinate on the line equals slope times x minus an x coordinate on the line. So I can start out with y minus the y coordinate equals our slope 2/5 times x minus our x coordinate minus -4 plus 4. Now, just to show you we could handle this a different way than what I handled number 3 up above, I might choose to multiply both sides by 5, but I know I just need to get y alone. So maybe I'll just leave y minus 1, distribute 2/5 x plus 2/5 times 4, 8/5 add 1 to both sides, but adding 1 onto fifths is the same as adding 5/5, and I get y equals 2/5 x plus 13/5. Number 9, write the slope-intercept form of the equation of the line through the given points. Okay, well, how does that differ from number 7 that we had? Now I have 2 points and I don't have a slope. So the first thing I need to do is find the slope. Well, we know that slope is rise over run, and rise, as the line moves and rises, that's how far the y changes. Run is how far the x changes. So we want the change of y. For instance, a y coordinate minus second y coordinate over an x coordinate minus a second x coordinate. That's our rise over our run. And you may have seen this before where it's y2 minus y1 over x2 minus x1. And the order doesn't matter so long as we're consistent. 1 to 2 and 1 to 2, or 2 to 1, 2 to 1. So the first thing I'm going to do is find the slope. My y's change from -3 to -5 as my x's change from -4 to 0. Or 2 on -4, -1/2. So I've just taken problem number 9 and turned it into problem number 7. Now I can choose either point I want, this point or the second point, but I have to use this slope. Well, I would choose the second point. There's a little gift 0 there. So y minus a y coordinate, that's y plus 5 equals -1/2 times x minus an x coordinate, x minus 0. I get y plus 5 equals -1/2 x. If I subtract 5, I'm left with slope-intercept form of y equals -1/2 x minus 5. Okay, number 11, write the slope-intercept form of the equation of the line described. So here we have a line that passes through 2 points, or a point, excuse me. So I know that this could be y minus 4 equals some slope times x minus -2, x plus 2. I just need a slope. But if I have parallel lines, they share the same slope. They're going in the same direction. So my slope is -5/3. So I just put -5/3 for my slope. And if the question just asked us to write an equation of a line through -2, 4 parallel to this line, I'd be done. But I need slope-intercept form, so of course S solve for y. I could multiply by 3. I think I'm just going to distribute through. Y minus 4 equals -5/3 x minus times plus minus 10/3. Add 4. But in thirds land, 4 is equal to 12/3. And I get y equals -5/3 x. Negatives versus positives fight. We subtract. The positives win by 2/3. So that's how we handle when we have a parallel line. Very simple. They're trying to disguise it and be tricky, but problem number 11 is really a lot like problem number 7. They've given us the point. They've really given us the slope. Now I'm not going to complete 12, but here we have the case of a line through 5, -3, and perpendicular to this. The slope we would use for perpendicular is opposite reciprocal. So reciprocate 3/5 and the opposite -3/5. So we would start off with y minus our y coordinate, y plus 3, equals -3/5 times x minus our x coordinate, and then solve for y. Okay, number 13, we shift gears a little bit. Here we want the standard form of the equation of each line. Standard form is defined as ax plus by equals c, where a is greater than or equal to 0, and we have no fractions, if at all possible. So the first thing I might do is I take a look at the line and I see I have a y-intercept of 3. I have a line that is going downward, so my slope is negative, and it's going down 1, 2, 3. It falls 3 as it runs 2. So I can get an equation of the line right now in slope-intercept form. Excuse me. So I have y equals m x plus 3. So that's great, and that would be wonderful if I just needed an equation of a line, but I'm supposed to be going for standard form. So no fractions, and a, the number times x, needs to be greater than 0. I need my x and y on the same side. First thing I'm going to do is eliminate fractions. I'm going to multiply both sides by 2. So I get 2y equals 2 times negative 3 halves is negative 3x plus 2 times 3, 6. Well, since I want my a term, this negative 3, I want it to be positive, I'm going to add 3x to both sides, and I get 3x plus 2y equals 6. And that is in standard form. Now, a lot of times at this point, you might have a negative value in front of the x. At that point, I'd multiply both sides by negative 1. Okay, so standard form. Again, you might want to just write yourself a note. That is ax plus by equals c. A should be positive, x and y on the same side, no fractions. So when they give me slope and intercept, though, I'm not going to start in standard form. I'm going to start in slope-intercept form. Y minus the y-intercept, or excuse me, my fault, y equals slope 2 times x plus the y-intercept plus 4. I started putting that in point slope form. I want to get my x's and y's grouped, so I could subtract 2x on both sides, and a negative 2x comes over, joins a positive y, leaves behind a 4. I do not want my a term to be negative, so I multiply both sides by negative 1. 2x minus y equals negative 4. And again, more with standard form. Here we have a line that's given to us in point slope form, like the point would be x value 2, y value negative 1, slope negative 1. But we're supposed to get this in standard form. So I'm going to go ahead and group my x's and y's as soon as I can. Distribute this negative 1, negative x minus times minus plus 2. I'm going to subtract 1, y equals negative x plus 1, and I'm going to add x. X joins a positive y, leaves behind a 1. Okay, I'm going to shift over to an even problem. So we'll deal with the fractional problem for the fraction for our slope here. Write the standard form of the equation line. Well, the standard form doesn't involve the slope, and I don't mind if I have integer values for a and b. So I'm going to go ahead and just take care of the fractions in the first step here on number 18. So I'm going to go ahead and multiply both sides by 5. 5 times y plus 4 is 5y plus 20. And again, remember, I only have to take 5 times either the x plus 5 or the 1/5. So I'm going to take 5 times the 1/5, and I get 1 times x plus 5. Or 5y plus 20 equals x plus 5. If I subtract 20 on both sides, I get 5y equals x minus 15. Group my x's and y's, subtract x. A negative x comes over, joins a positive 5y, leaves behind a negative 15. And at that point, I'm almost home, but I have to get rid of the negative in front of the x, times negative 1, both sides, and I get positive x minus 5y equals positive 15. So just a whole lot of manipulation. Everything's very, very similar. Standard form of an equation of a line given point with a given slope. So if I'm given a point and I'm given a slope, I'm going to use point-slope form. And again, that is y minus the y coordinate equals slope times x minus the x coordinate. And a lot of times I'll say that point-slope form starts with a p, and it's just puzzle pieces. I just need to put my puzzle pieces in place here. And I've got all of my puzzle pieces. Here's my y1, here's my x1, and here's my slope. So y minus the y coordinate equals slope 3/4 times x minus the x coordinate. Again, you could distribute the 3/4 here if you wanted to first, but I just want to get rid of fractions. I'm going to multiply both sides by 4. 4 times y minus 1, 4y minus 4. 4 times the 3/4, that's the whole reason I'm doing this, is just 3, which gets distributed to x plus 2. And you might do that in one step. 4y minus 4 equals 3x plus 6. I'm going to add 4. 4y equals 3x plus 10. I would then subtract 3x. And a minus 3x came over and joined a plus 4y, left behind a 10. I don't want that x term to be negative, times negative 1, both sides. 3x minus 4y equals negative 10. Okay, and maybe the most involved of these problems would be when we need to go to standard form of an equation and we're just given 2 points. Well, I always want a slope, so I'm going to find slope first. Slope equals, I always like using these arcs, and the students who use these arcs typically get these right. The y's change from -5 to -2 as the x's change from -2 to 5. So that's plus positive, negatives, positives fight, negatives win by 3, plus negative, negatives get along, -7, or negative divided by negative positive 3/7. And now I have more information than I need. I need a point, I need a slope. I've got a slope, I've got 2 points. I'm going to use this point. Point-slope form, puzzle pieces. Y minus the y coordinate, so that's minus negative plus 5, equals slope 3/7 times x minus the x coordinate, minus negative, that's plus 2. And if you've been paying attention, you know my next step. I like getting rid of fractions. Times 7. 7y plus 35 equals, 7's cancel, 3 times x plus 2, or 3x plus 6. I'll subtract 35. 7y equals 3x. Pluses mixed with minuses fight. The minuses win by 29. I'll subtract 3x. A minus 3x came over and joined a plus 7y, left behind a minus 29. And I'll multiply both sides by negative 1. 3x minus 7y equals positive 29. Okay. So just a whole lot of easy little steps. Write the standard form again of the equation of the line described. We pass through a point parallel to. Well, when they tell me parallel to, they're giving me the slope. The slope I want to use is 1, because this is 1x. So I want y minus 0, y minus the y coordinate, equals slope 1 times x minus negative 1, x plus 1. Or y equals x plus 1. Subtract x, negative x joins a plus y, leaves behind a positive 1. Do I always multiply both sides by negative 1? Nope, only when I have a negative coefficient in front of x here. X minus y equals negative 1. Okay, so again, number 26, the perpendicular problem, same thing except the slope we're going to use is the opposite reciprocal. We're going to use a slope of positive 3/2. And I'll leave that to the reader. Okay, so that gets us through the line portion of Chapter 1. Now some things we need to be really comfortable with, and I'm certain this is review, but review's good at the beginning of the year. Find each product we are to be multiplying. And when I multiply these, I have to multiply 2n by 6n and negative 5, and I have to multiply negative 4 by 6n and negative 5. And of course, you probably remember a little abbreviation for this. I'm going to multiply the first times the first. I'm going to multiply the outside terms. I'm going to multiply the inside terms. And I'm going to multiply the last terms. And we just have to be really careful with our negatives here, our minuses, but we just call this process FOILing. So first times first, 2n times 6n, 2 times 6, 12, and a pair of n's. Outside product, before I multiply 2 times 5, positive times negative, negative. Now 2 times 5, 10 with an n. Insides, minus times plus, minus 4 times 6, 24 with an n. And lasts, minus times minus plus 4 times 5, 20. And typically, not necessarily always, but typically we get grouping in the middle here. 12n squared, minuses mixed with minuses get along, minus 34n's, and plus 20. 29, I don't have a nice little FOIL abbreviation for this. I just call this super FOILing. I need to make sure I take 8a times each of these three terms and 7 times each of these three terms, and I handle it with the little arcs. Plus times plus plus, 8 times 7, 56 combined, they have 3 a's. Plus times plus plus, 8 times 2, 16, and a pair of a's. Plus times minus minus, 8 times 8, 64, and an a. Now I run the 7's underneath. Plus times plus plus, 7 times 7, 49, a pair of a's. Plus times plus plus, 7 times 2, 14 with an a. And plus times minus minus, 7 times 8, 56. So I just look for things I can combine. I start with the biggest exponents. The only to the third I have is 56a to the third. To the seconds, however, I have 16 and 49 of those. They're both positive, so they get along. I combine them. add 65a squareds, a's. I have minus 64 and plus 14. Minuses and pluses, fight, subtract. The minuses win by 50 a's and a minus 56. So it's just really a test in organization. Okay, solve each equation. We got some absolute values that we need to talk about. For our absolute values, we always should expect two solutions on absolute value problems. Doesn't mean we necessarily get them, but we expect them. And when does this turn into two problems? Well, you'll see we've got some differences, some more complicated looking problems here. For instance, in number 35, this 10n minus 8 is being governed by the absolute values. I need to isolate that before I start. In other words, I need to get this 5 to the other side. I need to get rid of this 7 as well. Likewise, 33, I need to get rid of this 1. I need to get rid of this negative 4. I want to get the absolute value portion isolated. But in number 31, little beginning problem, it is isolated. So once we have the absolute value isolated, I just call it split and switch. Split and switch. So we know what absolute values do. They turn things positive. Well, maybe the absolute value doesn't have to do anything. Maybe x on 3 is just equal to 1. But maybe x on 3 in here is negative 1 and the absolute value fixes it for us. So maybe x on 3, the inside part, if it was equal to negative 1, the absolute value would fix it for us. So there's our split. We split it into two equations, and there's our switch. So here we would just multiply by 3, multiply by 3, x is 3, multiply by 3, multiply by 3, x is negative 3. We could abbreviate that as x equals plus or minus 3. And we're at a dangerous point right now because a lot of people make the bad assumption that, well, then if one of the answers is 7, the other answer is going to be negative 7. Or if one of the answers is 4, the other answer is going to be negative 4. And you'll see that's not always the case. Okay, 33. As I was saying just a moment ago, I need to isolate this absolute value of 4x minus 10. So 4x minus 10 is most removed from this plus 1 out here. So I'm going to start by subtracting 1. I get negative 4 times absolute value 4x minus 10 equals negative 8. I'll see people at times here to get rid of this or rescue this negative 4, they might add 4. But this negative 4 is ultimately attached to the x with multiplication. I need to divide negative 4, and I get absolute value of 4x minus 10 equals, negatives cancel, 8 divided by 4, 2. And now we split and switch. Now I've got the absolute value isolated. So 4x minus 10 might just equal 2, but 4x minus 10 might equal negative 2, and then the absolute value fixes it. So we'll add 10, and you'll notice we do the same thing to the other side, we just get different results. So I get 4x equals 12, and 4x equals negative 2 plus 8 fight, positives win by 8. Divide 4, and I get x could be 3 or x could be 2. And I should mention earlier, I'd probably encourage you as you're going through these videos during the course of this year to, if I come up on problem number 35 and you're like, yeah, I know what I'm doing on this, maybe just pause the video, work ahead on the problem, you've got the worksheets, and then come back and check your answer. Okay, isolate. I'm going to add 5 to both sides, and I get 7 times absolute value 10n minus 8 equals 84. And I divide both sides by 7. We grab our calculator if we need it. Absolute value of 10n minus 8 equals 12. And now we're isolated, so now we can split and switch. Maybe the absolute value isn't necessary because maybe 10n minus 8 just equals 12. But maybe 10n minus 8 inside of here is equal to negative 12, and the absolute value makes it 12. So I will add 8, add 8, and I get 10n equals 20, or 10n equals negative 4. Divide 10, and I end up with n equals 20 divided by 10, 2, or negative 4/10. I would prefer for fractions, unless you're told differently, to round problems. Negative 4/10 reduces to negative 2/5. Okay, so along those same lines, when we get inequalities with absolute values, the beginning process is exactly the same. One tiny little switch to this as we move on. So first thing I want to do is isolate this guy. So I'm going to subtract 3 on both sides, and I get negative 4 times absolute value, negative 4 plus r. When I subtract 3 on an inequality, when I subtract on both sides of an inequality, the sign stays the same. Greater than, less than, stays the same. Negatives mixed with negatives get along, so we add those. We have a total of 16 negatives. Now, just a little side note here. If I was to say, we know that 4 is less than 12. If I was to multiply, or let's say divide both sides by negative 1, we know that this is a true statement. When I divide both sides by negative 1, I get negative 4 is less than negative 12. Is negative 4 less than negative 12? No, it's not. When we multiply or divide both sides of an inequality by a negative number, greater thans turn into less thans and vice versa. So my next step, I'm going to rescue negative 4 with division, and I'm going to circle this guy to remind myself I just rescued a negative using multiplication or division. That needs to switch. So I get absolute value negative 4 plus r is less than or equal to positive 4. Now, here's our split and switch step. Split and switch. I've isolated the absolute value. Negative 4 plus r might just be less than 4. But negative 4 plus, this is an r, plus r might be, here's the switch. It's a double switch on inequalities. I switch less than or equal to greater than or equal to, and I switch 4 to negative 4. Add 4. R might be less than or equal to 8. Add 4. R might be greater than or equal to 0. Let's take a look at our number line, how we would show that. I'm going to find 8 on the number line. 8 is here, and because I'm allowed to be equal to 8, I'm going to fill that in, say you can touch 8. If this was just less than, I'd leave a circle around 8. And this says I'm interested in numbers that are smaller than 8, this way. R greater than or equal to 0. I go to 0. It gets dotted. I want numbers that are bigger than 0, this way. And so now I've got my numbers between here, and that's the number line answer. But how do we communicate our answer? It's always going to be either with an and or an or. So I just look at a number and I see how does it relate to what I'm looking for. For instance, let's look at 3. 3 is one of my solutions. Well, 3 is bigger than 0 and it's less than 8. It's bigger than 0 and, so my final answer is r is less than or equal to 8 and r is greater than or equal to 0. Let's say we had an answer, let's say we had a number line solution that ended like this. Let's say we had 4 here and it went out, and we had 1 here and it went out this way. And now I look at my solutions. For instance, over here, 5. I could say 5 is bigger than 4, but not bigger than 1. So it's not bigger than 4 and, smaller than 1. It's either bigger than 4 or my answers are smaller than 1. For instance, here's -2 on the number line. -2 isn't bigger than 4, but it's smaller than 1, so it qualifies for one of those. This solution would be, for instance, x is less than 1 or x is greater than 4. The numbers I've chosen are either bigger than 4 or they're smaller than 1, but they're not both. Whereas this answer, 3, was smaller than 8 and it was bigger than 0. So be careful with our ands and ors. Ors shade outside, ands shade to the middle. Let's go through the remainder of this page and then we'll break for a second video. Okay, same process again here. I'm going to isolate my absolute value. I'm going to subtract 7 and I get 2 times absolute value, -7x. When I subtract, I don't change less than signs. 63 minus 7, 56. I have to rescue 2 before I split and switch. Absolute value, -7. When I rescue positives with division, signs don't change. For instance, 4 is less than 8. If I divide by 2, I get 2 is still less than 4, and that still works. So I get 56 divided by 2, 28. Now I split and switch. -7x might just be less than 28, but -7x might be, double switch it, greater than or equal to -28. Rescue -7 with division. I'm now rescuing a negative using division. Boy, it's easy to forget that step. Rescue -7 using division. I'm now rescuing a negative using division. Signs change. X is greater than or equal to -4. X is less than or equal to +4. Let's decide whether this is an and or an or. So I go to -4. It gets a dot because it can be equal to, and I want a shade bigger. I go to +4. It gets a dot because it's equal, and I want to shade values that are smaller than. I'm between, so for instance, 1. 1 is smaller than 4 and bigger than -4. Okay, just a few more here. Simplify each expression, and ultimately you're going to be able to do these. If you could do these in your head and do these quickly without showing steps, great. For right now, I'd like to see steps shown. Simplify each expression. I'm going to distribute. -4 times 4, -16. Before 4 times k, minus times plus minus. Now 4 times k. Before 6 times 7, it's minus times a plus, minus 6 times 7, 42. And before 6 times k, minus times a minus, plus 6k. So I'm going to group my k's first. I've got -4k's and 6k's. That's negatives mixed with positives fight, so we subtract. The positives win by 2. And my plain old numbers, negatives mixed with negatives or minuses mixed with minuses, get along, so we add. That's 58. We just got a whole bunch of minuses. 43. Please excuse my dear Aunt Sally. I want to do things in parentheses first. I can't combine these. Can't combine those. I look for exponents, parentheses, exponents, then multiplication, division. Well, here's multiplication and its distribution. So positive times positive, positive 6v. Positive times positive, plus 6. Now, this is multiplication. But before 8 times v, minus times plus, minus 8v. Before 8 times 4, minus times plus, minus 32. That sign right there be my biggest concern. If you ever see on a test or quiz MCAM, that's what I refer to as the most common algebra mistake, failure to distribute a negative. Be careful with that one. So I combine my variables. Pluses mixed with minuses fight. The negatives win by 2. Combine my whole numbers. Pluses mixed with minuses fight. Negatives win by 26. We'll go through 2 more problems. Just jump onto the next page. 45. Distribute this negative. Minus times positive, minus 8. Minus times plus, minus 2r. Distribute negative r. Minus times minus, plus r times 1. And minus times minus, minus 4r squared. The only r squareds I have are right here. R's, minus 2 of them, plus 1 of them. Minuses win by 1. And a plain old minus 8. Just things that we should be really, really strong at as we move forward in this course. And one more gets us to a good stopping point here. Number 47. Multiplication. Minus times plus minus 5 and a pair of p's, p squared. Minus times minus plus 5p times 3, 15p. Minus 8 times plus 5, minus 40. And minus 8 times minus 3p plus 24p. So we combine the only p squareds. P's, I've got positives mixed with positives get along for positive 39 p's and a minus 40. And we will pick it up from there on the next video.